All right, let's get right into it. Today, we're going to tackle one of the most mind-bending ideas in all of science. Can life actually survive in the absolute worst place you can possibly imagine? And I mean the freezing, irradiated vacuum of outer space.
You know, when you look up at the night sky, what do you really see? For most of us, it's just this vast, silent, black emptiness, right? That's what we're all taught. But is that what's really going on out there? Not even a little bit. The reality is, well, it's way more extreme. Space isn't just empty. No. It's an environment that is actively, and I mean violently hostile to just about any life we can think of. So before we can meet the incredible little creatures that survive this cosmic nightmare, we first have to really understand the enemy. We have to appreciate just how unbelievably lethal space actually is. See, anything in space faces what some scientists call the trinity of death. First up, the vacuum. With no air pressure, the water inside your very cells would just instantly boil away. Gone. Second, radiation. You've got this constant storm of solar and cosmic rays that acts like a microscopic machine gun, just shredding DNA to pieces. And finally, the temperature swings are insane. You can go from minus 120 Celsius in the shade to a blazing plus 120 in the sun in just a matter of moments. I mean, that combo should destroy the fundamental building blocks of life in seconds. It just should. And yet, against all of these impossible odds, some of the smallest, tiniest organisms on our own planet have somehow figured out how to become the ultimate survivors. So it is time to meet the heroes of our story. They're a really special class of microbes called extremophiles. And trust me, they are nature's undisputed champions of survival. Let's meet a few of them. First up, you've got Deinococcus radiodurans, which has the awesome nickname Conan the bacterium because of its insane resistance to radiation. Then there's Bacillus subtilis, or the time traveler, because it can basically just hit pause on being alive. And last but not least, Glocapsa, the shield bearer, which has this, well, it's a pretty grim but totally brilliant strategy for staying safe. Okay, so how? How do they actually pull this off? Surviving out there isn't about having some kind of impenetrable shield. No, it's about having an ingenious and, frankly, unbelievable survival playbook. Let's start with Conan the bacterium. Its big secret isn't preventing damage. It's about repairing it at lightning speed. So yeah, radiation does shatter its DNA into hundreds of tiny pieces. But then this little army of special proteins just springs into action, gathering up all those fragments and perfectly reassembling them. We're talking within hours, with zero mistakes. It's like putting a shredded puzzle back together in a hurricane. It's basically biological magic. Then you have the strategy of Bacillus subtilis. It's called cryptobiosis, and this is essentially a zombie state. The bacterium just shuts down everything that makes it alive. No breathing, no eating, absolutely zero signs of life. It turns itself into a hardened little spore. It's not really alive, but it's not dead either. It's just waiting. And it can wait like that for thousands, maybe even millions of years. And the other tricks are just as wild. Remember Glocapsa, the shield bearer? Well, it lives in colonies, and when it gets blasted with radiation, the outer layer of bacteria just dies. They form a literal shield of corpses to protect the living bacteria underneath. I mean, how crazy is that? Others have even developed these pinkish pigments that act as a kind of natural built-in sunscreen. And get this isn't just a theory they figured out in a lab. We've actually proven these superpowers work in the most extreme laboratory imaginable, space itself. Let me introduce you to the Japanese Tunpopo experiment. Scientists took dried-out clumps of our hero bacteria, Deinococcus radiodurans, and they literally stuck them to a panel on the outside of the International Space Station. Not inside where it's all safe and cozy, but out in the open void. And they left them there for 3 full years. That's 3 years of being absolutely blasted by raw solar radiation, cosmic rays, and the absolute vacuum of space. So what do you think happened? Well, when they brought the samples back, they found that the bacteria on the very top layer of the clump, they were dead, just as expected. But in dying, they had formed that shield of corpses protecting the bacteria underneath. And those shielded bacteria, yeah, they were still alive. The conclusion from this is just staggering. The data suggests that a clump of bacteria, just 0.5 millimeter thick, that is smaller than a grain of sand, has what it takes to survive a journey between planets. So, this is where the implications get really big. Because if tiny organisms can survive interplanetary travel, it forces us to ask a really profound question about our own origins. This brings us to the theory of lithopanspermia. It's the idea that life didn't actually start here on Earth, but that it was imported. Just imagine an asteroid hitting an ancient, wet Mars, blasting rocks full of microbes out into space. Those rocks could drift for millions of years, with the bacteria sleeping in their zombie state, until one day, one of them crash lands on a young Earth. The Tampopo results really transform this idea from pure science fiction into a valid biological possibility. But this incredible knowledge also creates an enormous responsibility, especially for organizations like NASA as we continue to explore our solar system. We now have to worry about two huge things. First is forward contamination. That's the risk that we accidentally send a rover to Mars with some tough little Earth bacteria clinging to its wheels, which could totally mess up our search for native Martian life. And then there's the flip side, back contamination. The risk that we bring samples back from Mars that contain alien microbes that could be really harmful to our own planet's ecosystem. So what's the big takeaway here? Well, this research fundamentally changes our view of the cosmos. It tells us that life is just far more resilient than we ever gave it credit for. It suggests that the habitable zone might not just be a perfect Earth-like planet, but could be hiding in all sorts of extreme pockets around the universe. And it shows that on a microscopic level, the line between being alive and not alive is surprisingly blurry. Which leaves us all with one final tantalizing thought. If life can survive the absolute worst the universe can possibly throw at it, where else out there is it hiding?